This is Prashanth. I am going to give a brief discussion on the topic of introduction to wireless communications and networks. So before entering into that wireless communications and network, one see what is communications and what is network. So the topic contains initially two words: wireless communications and network. So what is communication? What is networks? How the communication will process among the wireless devices with formation of the network. So generally we are in 2022. So in 2022 there is a plenty of wireless technologies in front of us. So in order to utilize that, we have to study some protocols, some devices like that only we have to study. So wireless communication networks will follow the some disadvantages, some advantages over the wide communication network. So simply the networks is nothing but interconnection of two or more networks. Within that we have to build communication among the devices. So in order to play with the communication, we have only three devices here. So in order to build the communication among the devices, we need only three devices initially. One is the transmitter, second one is the receiver. So when that signals are transmitted from the transmitter, the receiver automatically receives the signals. The signals are passing through the channel. So in order to explain the communication system, initially we need only three parameters like transmitter, channel and receiver. So this is about some few points regarding wireless communications and network. Let's move on to the these are the some wireless devices like GSM module, RF module, GSM module, RFID, Wi-Fi, infrared and Bluetooth and GPS. So these are the examples for wireless devices which are used to develop the communication among the devices. Let's start with the RFID, radio frequency identification. In radio frequency identification, the data will store in the form of radio signals, will pass through the radio signals. It consists of information in the RFID card. Next, GSM module. So GSM stands for Global System for Mobile Communication. So it is developed by the US. And radio frequency identification. Next, Wi-Fi module. Wi-Fi stands for wireless fidelity. Next, infrared, Bluetooth and GPS. So every communication module having some advantages. Apart from that, some disadvantages. So in order to overcome the disadvantages, we need some new technology. Next, move on to the introduction of wireless communications and network. In wireless communication network, it is the fastest growing and most vibrant technological areas in the communication field. So we already know the communication system will follows fastest and growing methodologies. So in the part of communication, it is a method of transmitting information from one place to another place. So next, without using any connection like wires, cables or any physical media. Next, antennas are electrical devices that transform the electrical signals to the signals in the form of electromagnetic waves. So generally, in order to build the communication, first we need transmitter. So that transmitter transmit the signals in the form of electromagnetic waves. So that electromagnetic waves are transmitted through the transmitting antenna. Next, these electromagnetic waves propagates through the space. Hence, both transmitter and receiver consist of the antenna. We have transmitting antenna along with the receiving antenna. Next, wired communication can do most of the tasks that a wireless communication can do. Why we need wireless communication? So it is the reason why we are maintaining some wireless devices in the current technology, in the part of current technology. The primary and important benefit of wireless communication is the mobility. So you can use in anywhere in the world, the wireless device can work. So depending upon our requirement. So this is the main difference, is the mobility is the main advantage over wired communication. Next, another important point is infrastructure. The setup and installation of infrastructure infrastructure is a wide communication system is an expensive and time consuming job. Next, move on to the another point. The infrastructure for wireless communications can be installed easily and low cost. So simply they can drag the wireless device and connect it to the wireless or whichever wireless communication available in our home. Next, the emergency situations, remote locations where the setup of wide communication is difficult and wireless communication is a viable option. So these are the some points regarding why we are go for wireless communication over the wide communication. Next, move on to the some advantages of wireless communications. So here we have so many advantages of wireless communication. So apart from that, we are going to discuss some 2-3 advantages over wide communication. So wireless networks and wireless systems over the wide communication, like cost, mobility, and ease of installation and reliability. So these are the few advantages of wireless communication system. The first one is cost, mobility, and ease of installation and reliability. So let's start with the first point, the cost. So the cost of installing wires in the wide communication, the cost of installing wires, some other devices, other infrastructure is eliminated in wireless communication, and hence the lowering of overall cost of the system compared to the wide communication system. So generally, installing of wires, developing of infrastructure is very cost as compared with the wide communication. Next one, in historical buildings, drilling holes for cable is not a best idea as it destroy the integrity and importance of the building. So this is one of the disadvantage of wide communication. Next, also in older buildings with no dedicated lines for communication, wire communication like Wi-Fi or wireless LAN in the only option. So these are the advantage of wireless communication in terms of cost. So easy of installation is very easy in the wireless communication compared with the wide communication. Next, move on to the second advantage of wireless communication. It is the mobility. So you can move anywhere in the world. They can connect to the devices very easily. So mobility is the main advantage of wireless communication system. It offers the freedom to move around the while still connected to the network. So easy of connection, easy of move in anywhere in the area. Next one, easy of installation. So easy of installation means the setup and installation of wireless communication networks, equipment and infrastructure is very easy, as we need not worry about the hassles of cable. Next, also the time required to set up the wireless communication like Wi-Fi network area, for example, very less than compared to setting up a full cable network. So these are the some advantages of wireless communications. Next, move on to the in terms of reliability, since there is no cables and wires involved in wireless communication network. So there is no chance of communication failure due to the damage of these cables, which may be caused by environmental conditions, cable splices, and natural diminution of metallic conductors. So if you maintain wide network in the rainy season or any other, so due to the rain, the cables are easily going to destroy. So that is one of the disadvantage of wide communication. So if you maintain the wide communication, we are facing like that problems. The cables are destroyed, the cables are destroy like that. Next one, disaster recovery. So in case of accidents due to the fire, floods, and other disasters, the loss of communication infrastructure in wireless communication system can be minimal. So these are the some disadvantages in terms of disaster recovery and reliability. Next, move on to the disadvantages of wireless communications. So advantages of wireless communication, apart from that, along with some disadvantages also are there. So that is in terms of interference. So in sometimes the signal may lose or the signal may destroy, or the signal may interfere with the other signal. So that is called interference of the mixed signal. So here in terms the disadvantage in terms of wireless interference. So we have in communication system, we have so many interference like co-channel interference, adjacent channel interference, like that we have so many interference. So this is the basic terms of interference. The wireless communication system uses open space as the medium for transmitting signals. As a result, there is a huge chance that the radio signals from one wireless communication system or network might therefore with the interfere with the other signal. So easily the signals can mix with the other signals due to the propagation losses. So in order mixed with the other signals due to the propagation losses, the best example is Bluetooth and Wi-Fi. Both these technologies used at 2.4 gigahertz frequency for communication, and both of these devices are active at the same time. There is a chance of interference. So this is one example for interference from the Bluetooth and wireless technology. Next, installing wide network in buildings, digging up the earth to lay up the cables and running those wires across the stretch is extremely difficult and cost and the time consuming job. So this is one of the disadvantage of wireless communication. So in order to overcome the interferences, we have so many methods. So that methods we are going to study in the future. Next, in terms disadvantage in terms of security. So one of the main concern of wireless communication is security of the data. So someone nowadays there is a so plenty of cyber crime, cyber security problems with we are facing. So since the signals are transmitted in open space, it is possible that an intruder can interrupt the signals and copy the sensitive information. So security is the one of the major concern nowadays. So in order to overcome that, we have so many, we follow so many other technologies. That is the second part. Next, health concern. So continuous exposure to any type of radiation can be hazardous, even though the levels of RF energy that can use the damage are not accurately established. So it is advised to avoid the RF radiation to the maximum. So these are the some disadvantages in terms of interference. So in order to overcome the interference, we have so many methods. Next one, in terms of security, in terms of health concern. So these are the some disadvantages of wireless communication system. Next, move on to the this is the basic block diagram of communication system. So in any communication, start with basic information. The information means it consists of information in terms of symbols, pictures, either in many mathematical form. So the information source or the information block, which consists of information in terms of either symbols or pictures or any other mathematical formulas. So that information, some amount of information can pass through the source encoding. So what is the main function of source encoding? So the received signal from the information, the source encoding, it converts into the some other parts, that is encoding. So it encode the data for security reasons. So the security encoded while information can pass to the encryption. So the encryption apply some codings to the received signal, then immediately it pass to the channel encoding. So in the channel encoding, the function of the channel encoding, it pass to the modulation. So here we can do so many modulation techniques in the analog communication or digital communication, like AM, FM, DSB, SC, SSB, like that. So according to our requirement, we can do the modulation in the modulation box. So for voice signals, we can do amplitude modulation. For video signals, For video signals, we can do VSB, vestigial sideband signals. So for audio transmission, we can SSB, single sideband suppressed carrier, or DSBSC, a double sideband with suppressed carrier modulation techniques we can do in the modulation box. So after modulation, the signals are moving to the multiplexing. So the main function of multiplexing is it can pass many signals through the single channel. So what is the main function of multiplexing? We have to transmit many more signals through the single channel. That's why here we are using multiplexing. So many more number of signal can pass through the single channel only. That is the multiplexing. So the after multiplexing, the signals are passed through the channel. This is the wireless channel. So the wireless channel. So after receiving at the receiver, so the same process will do in the reverse direction only. So here it is the last part of the transmitter part is, so this is the transmitter path. This is transmitter path. This is the receiver path. So the last part of receiver transmitter path is multiplexing. So the first part of multiplexing receiver is demultiplexing. So demultiplexing, it is the reverse direction of multiplexing. So here multiplexing means we can pass more number of signals through the single channel only. So that single channel transmitted signals can receive at the receiver by using we can decode that demultiplexing of the signals. So the demultiplexed signals can pass through the demodulation. So in the demodulation, we can get the required signal from the modulated signal. So our information, we can get the demodulation box. So after demodulation, so the entire signal can pass through the channel decoding. So here we have a channel encoding block. So here we have a channel decoding block. So after channel decoding, the entire signals can pass through the description block. So after the source decoding, so here we get the esteemed information. So this is the basic block diagram of communication system. It starts with the information to we get the esteemed information. So the esteemed information can approximately equal to the actually what we are passing the at the input. So this is about basic elements of wireless communication system. So the wireless communication system block diagram start with information, source encoding, disk encryption, channel encoding, modulation, multiplexing. After multiplexing, we can pass through the signals through the wireless channel, not wired channel. So after wireless communication channel, so the entire process will be in backward direction: demultiplexing, demodulation, channel decoding, description, and source decoding with esteemed information. So the esteemed information approximately equal to the actually we are passing at the input of the transmitter. So this is about basic elements of communication system. Next, move on to the introduction of actual our subject. So in the part of wireless communications and network, first we are going to study cell concept. So here the cell concept is a system level idea which calls for replacing a single high power transmitter with many lower power transmitter. So generally we have to transmit the signal from the transmitter. So we have to measure some parameters like transmitted power, transmitter efficiency, transmitter gain, like that we are measuring the parameters for transmitter. So here in the cellular concept, why we are introducing cellular concept here? So we are replacing the single high power transmitter with many low power transmitter. So due to that, the capacity of the cellular system automatically will improve, and capacity of the system will improve. So the cellular concept is based on replacing a single high power transmitter with many low power transmitter. So many low power transmitters means each transmitter having on base station the base station. So it offers very high capacity in a limited spectrum allocation. So automatically when you are replacing high power transmitter with many low power transmitter, automatically the capacity of the system will increase. That is mentioned in the second point. So it offers many very high capacity in a limited spectrum allocation. Next, each base station is allocated portion of the total number of channels available to the entire system. So each base station is allocated a portion of the total number of channels available to the entire system. The neighboring base stations are assigned and different group of channels so that interference between the base station is minimized. So our agenda is to improve the capacity of the cellular system, and we need to minimize the interference between the two stations. So these are the two agendas. The first one is improve the capacity by replacing the single high power transmitter with many low power transmitters. Next one, in order to minimize the interference between the base stations, assign each each base stations are assigned to different group of channels. So each base station is assigned to different group of channels. So by these two reasons, we are going to achieve our goal in the cellular system. So this is the part of introduction. So here the diagram is like that. So this is the cell size that is comes in the next slide. So it is BTS1, BTS2, BTS3, base transceiver, base transceiver, MTS for mobile switching station for next mobile phone system. Actually our mobile phone system works based on this diagram here. So here some terminologies we are going to use in our subject. So these are the some terminologies. So here one is the BS. BS stands for base station. So here the base station is here base station. The second one is BTS, base transceiver station. So here base, it is a not base transmitter station or base receiver station. So it is the transceiver. The transceiver is nothing but transmitter plus receiver. So it acts as a two modes, either transmitting or receiving. That's why it is BTS, base transceiver station. BTS stands for base transceiver station. Next one, BSC, base station controller. It controls the working of all the base stations. So here it is the major of the base controllers. So it controls the working of all the base stations here. Next, MSC, mobile switching center. It master control of the entire system. So these are the some terminologies we are going to use in our subject. So here the mobile station 1, mobile station 2, mobile station 1, mobile station 2, here mobile station 3. So after mobile station, the signals are moving to the BTS, base transceiver station. So after that, BTS will send the signals to the BSC. What is BSC? Control the working of all the base station. So after BSC, the signal move to the MSC1. MSC means master control of the entire system. So the MSC1 can transmit the signals to the other MSC2, other master control of the entire system. So this is the process of mobile phone in our daily life. Okay, so these are the some terminologies we are going to use in our subject. BS, base station. BTS, base transceiver station. BSC, base station controller. It controls the working of all the base stations. Next one, mobile switching center, master control of the entire cellular system. So these are the some terminologies. So here each base station is allocated a portion of the total number of channels available to the entire system, and nearby base stations are assigned to the different group of channels, so that all the available channels are assigned to a relatively small number of neighboring base station. As the demand for services increases, the number of base stations may be increased, thereby providing additional radio capacity with no additional increase in the spectrum. This is the fundamental principle of cellular system. So generally, the total number of available channels to enter, total number of channels available to the entire system, it is assigned to the different group of channels. It is okay. So the fundamental principle of cellular system is, as the demand for service increases, as the demand for service increases, is nothing but number of users may increase beyond the required channels. So the number of base stations may be increased. So it can increase the number of users increase, automatically the effect will work on the base station. So automatically we need to increase the number of base stations only. Okay. So the base station may be increased, thereby providing a additional radio capacity with no additional increase in the radio spectrum. Okay. So this is the fundamental principle of cellular system. Next one, cell shape. So in order to discuss about frequency reuse concept, so the first, the geographical area in our country or in our world, so the area will divided into some unit of geographical area. So simple, one unit of geographical area is nothing but one cell. So here the cell shape, we are going to discuss the cell shape. So here geometric shape cover an entire region without overlap and with equal area. So here, so the entire area can divide it into some parts. Okay, so the parts is nothing but one unit of geographical area. So the cell shape, so the unit of area is, the shape is hexagonal shape, we are decide. So here by using hexagon, the fewest number of cells can cover geographic region, and the hexagon closely approximate a circular radiation pattern which would occur for omnidirectional antenna. So here omnidirectional antenna, it radiates the energy into all directions equally. So here, so the shape of the unit of geographical area is hexagonal shape. So why we are choosing the shape for unit of geographical area hexagonal is, there is a reason, reasons are there. So if you choose the circle, the shape of unit, there may be a overlap. So from this we may get some loss of information. So if you choose square, so there may be a overlap like that. So equilateral triangle also, it cannot cover the entire region of the area. So that's why we are using where we choose hexagonal shape to denote the area. So here, so this is the main difference why we are choosing cell shape hexagonal as compared with the square. So it is the square shape. From the center point, it is from here to here, the center point here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So here the middle one is the fifth one. So the center point from fifth to the center point 2 is the distance d. Just you assume. So from 5 to 3, root 2 into d. So the radius between the distance between the 2 and 5 is the d. The distance between the 3 and 5 is the root 2d. So it is not equal. So it is not suitable to explain anything. Okay. So if you choose the hexagonal shape to denote the area, so from center point to anywhere, so the distance at all points are equal. Okay. So the distance d at equal or constant. Okay. So from here to here the distance d, from here to here d, here to here d, d. So here this is the radius from the sharp edge. Okay. So this is the cell shape of cellular system. Next move on to the first important topic is frequency reuse. So here, what is frequency reuse first? So in the communication system, the signals are passing from the transmitter to receiver, it is okay. So the transmitted signals having basically three parameters. The one is the frequency, second one is the amplitude or voltage, next one is the phase. So these three parameters, the it passing having some frequency, so that frequency used in another cell, so as per our requirement, that is called frequency reuse. So the just I can elaborate the words of frequency reuse by studying this. So by limiting the coverage area with the within the boundaries of a cell in the small group of channels may be used to cover the different cells that are separated from one another by distance large enough to keep interference level within the tolerable limits. So here, by limiting the coverage area to with the boundaries of a cell, the same group of channels may be used to cover the different cells are separated from one another by another. Okay, so the design process of selecting and allocating channels frequencies for all cellular base stations within the system is known as frequency reuse or frequency planning. So what is the another name of frequency reuse? Frequency planning. So in order to increase the capacity of the system, so we use one method I already told in the interference. So in order to increase the capacity of the system, one method is frequency reuse planning. So how the frequency reuse planning will implemented with real time, I will discuss. So here, for example, this is one of the cluster. So one cell is one cell. Group of cell is nothing but one cluster. One cluster. 1, 2, 3, 4, 5. So this is a group of cells is nothing but one cluster. So here one cluster having 7 cells neighboring. So here this is F1, 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 F1. So for F1 having F2, F3, F4, F5, F5, F6, F7. So this is one cluster. This is another cluster. This is another cluster. This is fourth cluster. So here in this diagram we have 4 clusters. Each cluster having 7 cells. Okay. So here the blue indicates frequency reuse planning. Okay. So F1 frequency used in the first one, in the second one, in the third one, and this is the fourth one. Okay. Now, so F1 frequency we are using here, F2, F3, F4, like that. So in order to implement the practically frequency reuse, we use one formula that is going to discuss later. So it is from here to here, it is the reuse distance. One factor is reuse distance, capital D. Okay, so it is the set of frequency. It is the 7 cell reuse cluster. Okay, so let's move on to the frequency. The concept of cluster we already know. So it is a group of cells is nothing but one cluster. So depending upon our requirement, the cluster having many number of cells also. So but our requirement is here, the best suitable cluster is n is equal to number 7. Okay, so the numbers n is equal to 7 it is very convenient to all. So the consider a cellular system which has a total S duplex channel available to use. Okay, so the S channels are divided into n cells, is nothing but one cluster. Next, each cell is allocated a group of K channels. Each cell is allocated a group of K channels. So here total S duplex channels, capital S, N cell, capital N cells, K channels. So from these three, I can write the formula S is equal to K into N. Okay, so from this we get one mathematical formula. S duplex number of channels is equal to K into capital N. So here the n cells which collectively use the complete set of available frequencies is called a cluster. Okay, so the cluster size is n is equal to 4, 7, 12. The frequency reuse factor is 1 by n. So these are the some points regarding the cluster. So here the cluster size is denoted by capital N. The capital N is equal to 4, 7, 12 or any other. So denoted by capital N. So the frequency reuse factor, in some numericals they are asking find out the frequent number of cluster size or number of duplex channels or group of k channels, like that. So if you know the 3 parameters, you can find another parameters easily by using given 3 parameters. Next frequency reuse factor is 1 by capital N. So this is about the concept of cluster in the part of frequency reuse. So next one, frequency reuse distance. So here there is a 2 cluster. This is the first cluster. This is the second cluster. So the cluster having group of cells is nothing but cluster. So here n is equal to 7. The cluster size is n is equal to 7. So here f1 frequency, f1, f2, f3, f4, f5, f6, f7. Here f1 same group of channels. So the center point for f1 to this f1, the distance is frequency reuse distance, that is capital D. So for hexagonal cells, the reuse distance is given by D is equal to root 3 into n into r. Okay, now so here D is the reuse distance, capital D is equal to root 3 into number of cell size, and r is the radius of the each cell. Okay, so where r is the cell radius, n is the reuse pattern, the cluster size of number of channels per cluster. Next, frequency reuse factor. Reuse factor is given as capital small reuse ratio. Q is equal to capital D by R. Approximately it is equal to root 3 into n. So this is the formula for frequency reuse distance. Reuse distance capital D. Next one, in order to find out reuse distance, so here in previous slide just we get root D is equal to root 3 into n into r. So how the formula is getting? So here the cluster size or the number of cells per cluster is given by the formula n is equal to I square into ij plus I square. So here, so for example, this is the one cell hexagonal shape. So from center point, so in the formula we are mentioning 2 parameters. I is the one of the parameters, second one is the j. So these two are the directions from the center point of a particular cell. So here this is the center point of the particular cell. So from here to here the direction of I is like that. Okay, so approximately 60 degrees from the this line. So approximately it is 60 degrees from here. The direction of J is like that. So like this we have to determine the cluster size, that is both the values are substituted in the n is equal to I square plus ij plus j square. Then we will get the cluster size capital N. So I and j are the integers in number. So n is equal to 1, 3, 4, 7, 9 like that up to the maximum number. So among all the values, n is equal to 4, n is equal to 7 is the popular value for n being is n is equal to 4 and 7. So why we are choosing the popular values for 4 and 7? Let's see with one example here. So here finding the center of an adjacent cluster using integers I and j, direction of I and j can be interchanged. So here from this is the formation of a cluster with n is equal to 7. So here 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So it is the cluster having 7 number of cells. Okay. So the center point of the one is this one. So from I direction is state direction here, state direction here, state direction here. So from here to here there is a one from center point to the center point I is equal to 1. From here to here one more radius I is equal to 2. So from this 60 degrees integer value, then j is equal to 1. So substitute I is equal to 1, I is equal to 2, j is equal to 1, I square plus ij plus j square. Okay. So 4 plus 2 plus 1, that is the values of n is equal to 7. That's why the compatible value for cluster size n is equal to 7 for frequency reuse. It is very important factor. N is equal to 7 cell pattern. So by substituting the values of integers I is equal to 1 or j is equal to 2 or j is equal to 1 and I is equal to 2. So the values can interchange, but the value is given n is equal to 7. So this is the proof of why we are choosing n is equal to 7 cluster site. So I direction, this perpendicular direction. So apart from there is a 60 degrees, then you will get to j value. Okay. So from here from here to here I is equal to 3. From here to 60 degrees value j is equal to 2. So substitute these two values, you will get n is equal to 19. So for example I is equal to 3, j is equal to 2, I square plus ij plus j square. So I square 9, 6 plus 4, 9 plus 6, 15 plus 4, n is equal to 19. So n is equal to a cluster size with n is equal to 19 with I is equal to 3, j is equal to 2. So a cluster size with n is equal to 12, so I is equal to 2, j is equal to 2. So from here to here I is equal to 2, from here to here j is equal to 2. So substitute both values in this formula, I square plus ij plus j square, you will get n is equal to 12. So this is not suitable for us. So only n is equal to 4 or n is equal to 7 to use for frequency reuse concept. To implement the frequency reuse, we will follow I is equal to 1, j is equal to 2 integer values. That is the best one. Next one, frequency reuse pattern. Frequency reuse pattern. So is n is equal to 7 frequency reuse pattern. 1, 2, 3, 4, 5, 6. It is okay. So here this is one cluster. This is another cluster. So from here to here, this is the distance. The frequency reuse distance from one to center point of one value is okay. So the co-cells for n is equal to 19. N is equal to 19. So from here to here, here to here, here to here. So I value it is equal to 3. From here to here, here to here, j is equal to 2. So I is equal to 2, I is equal to 3, j is equal to 3. Both values substitute in I square plus ij plus j square, you will get n is equal to 19. So how can you take I is equal to 3 value? So from center point to this one it is 1. From here to here this is 2. From here to here this is 3. J value. From here to here this is 1. From here to here this is 2. So I is equal to 3. These two, j is equal to 2. Okay. So from this, this is the proof I is equal to. How can you take I is equal to some value, j is equal to some value? So you can measure the distance between the center points of the cells. Okay. So from center point A to second cell, from here to third cell, from here to fourth cell. Okay, na? So among 4 there is a 3 distances, 1, 2, 3. Then the I is equal to 3. Okay, so among 3 here for J, among 3 we get to 2 radius. J is equal to 1, J is equal to 2. So like that, this is the frequency reuse pattern. So same A here at the same place, same frequency you are using. So for example, here 10 kilohertz frequency channels are used. So here only 10 kilohertz. There may be a chance of reusing same allotted frequency channels. Okay, so like that we are going to implement frequency reuse in the cellular concept to to increase the capacity of the system. Okay, so next one, some formulas here. We already know the total number of available channels in the system is capital S is equal to capital K into N. N number of channels, N is the cell size, that is either 4 or 7 as per our requirement. So here total number of available duplex channels in the cellular system, that is S. Next one, K number of channels per cell, always K less than S only. So you have to remember this formula when you writing the S is equal to K into N, or when you solving the numericals by using this formula, K is equal, K always less than S. So the N is the cluster size, each cell having K channels and S channels in a cluster. Next, if cluster is replicated in M times. Okay, so if the cluster is replicated M times, the total number of duplex channels then measure of capacity. So it is C is equal to capital M into small k into N, that is M into S. Okay, so C is equal to M k into N. So Kn is nothing but S. So finally C is capacity. In order to measure the capacity of the cellular system, the C is equal to capital M into S. This is some formulas in order to solve some numericals on the frequency reuse. Next, frequency reuse, some example diagrams here. So we have only 2 main formulas. S is equal to K into N. Some number of duplex channel is equal to K number of K into cluster size N. Next, capacity. In order to find out the capacity of the total system, compulsory in numerical they are asking C is equal to M into K into N, that is M into S. So frequency reuse for N is equal to 4, here it is N is equal to 4. So how can you identify? So here this is the cluster, or this is cluster only. N is equal to 4 means only 4 cells we have, 1, 2, 3, 4. Okay, so it is frequency reuse pattern for N is equal to 4. So it is for N is equal to 7. 1, 2, 3, 4, 5, 6, 7. It is for N is equal to 7 frequency pattern. So it is N is equal to 19. We already know. So from here to here, here to here, here to here, here to here. So I is equal to 3. J is equal to 2. So substitute these 2 values in the formula, we get N is equal to 19. Okay, so this is the proof for N is equal to 4, N is equal to 7 and N is equal to 19. Remaining part continue with the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.